Hey everyone! Today, we are pulling back the curtain on code. Using some awesome study materials from CompTIA, we're going to map out the fundamental blueprint for how pretty much any piece of software gets built, from just a simple idea to the apps you use every single day. Let's get into it.
I mean, think about it. It really can seem like magic, right? You tap a little icon on your phone, and boom, a whole world just opens up. But behind every single app, every website, every program, there's a logical, step-by-step process.
And that's really the best way to think about this. Building a program is a lot like building a house. You don't just show up and start nailing boards together, right? You need a detailed plan, you need the right materials, and you've got to understand how it all fits together. Well, programming, it's the exact same deal.
Okay, so first things first, every builder needs a tool set. In the world of programming, our main tool is the language we decide to write in. And believe me, not all languages work the same way.
The biggest difference really just boils down to this. How does the computer actually understand your instructions? Interpreted languages like Python or JavaScript are kind of like having a live translator. The code is read and executed line by line, which is amazing for quick development and testing. On the other hand, compiled languages like C++ are translated all at once into the computer's native tongue. This creates a super efficient file that can run incredibly fast.
And you can see this in action right here. We've got interpreted languages like Python and PowerShell, which are often the go-to for scripting and automation. Then you have the compiled heavy hitters like C++ and Java, which are what you pick when performance and raw speed are absolutely critical. And then, kind of in a league of their own, are markup languages like HTML. They don't really execute logic, but they are essential for structuring content on the web. And then, of course, you've got your specialists. There's assembly language, which talks almost directly to the computer's hardware. It's super complex, but incredibly powerful for things like IoT devices. And then you have query languages, the most famous being SQL, which is basically the universal language for talking to databases.
All right, so we've picked our tools. Now what? Well, now we need our building materials. In programming, that material is data. And we have to be really specific and tell the program exactly what kind of data it's going to be working with.
These are the absolute basics, the fundamentals. A Boolean, that's just a simple true or false, like an on-off switch. An integer is any whole number, like 10 or -50. A float is a number that has a decimal point, like 3.14. And a string is just text. Could be anything from a single letter to a whole paragraph.
But here's the thing. Choosing the right type is so important. And this example from the guide shows exactly why. Let's say you have a zip code like 01234. If you store that as a number, that leading zero just vanishes and it becomes 1234. But by storing it as a string, as text, you keep the data exactly as it's meant to be. It seems like a small detail, but it can have huge consequences.
Okay, so we have our materials. Now we need a way to store them and keep them organized while we're building. We need containers.
The two most basic containers you're going to use are variables and constants. A variable is like a labeled box where you can change what's inside any time. Think of a user's score in a game. A constant, on the other hand, is like a box that's been sealed shut. You set its value once and it never ever changes, kind of like the value of pi.
But what if you have a whole bunch of similar items? You wouldn't want to create 100 different boxes for 100 student names, right? Of course not. Instead, you'd use an array. Just think of an array as a big shelf designed to hold an entire collection of the same type of thing. It makes it super easy to manage a list of names or maybe daily temperatures.
Now, here's a key concept in programming you just have to get used to. Arrays are zero-indexed. That just means the first item isn't at position 1, it's at position 0. So if you want to grab the very first thing in an array called ages, you'd ask for ages 0. It's a little weird at first, but you get the hang of it fast.
So we've got our tools, we've got our materials, and we know how to store them. Now, before we write a single line of actual code, we need that blueprint. We have to sit down and actually plan out the program's logic.
One of the best ways to do that is with something called pseudocode. It's not a real programming language. It's just a way of writing out the steps of your program in plain English. This lets you focus completely on the logic without getting bogged down by the specific rules of a language like Python or C++.
So if pseudocode is your written outline, a flowchart is your visual diagram. It lets you map out the flow of your program using standard shapes, so you can literally see how the logic is going to move from one step to the very next.
And these are the basic symbols that will map out your program's journey. You've got ovals, which mark the start and end points. You have rectangles, which represent an action, like calculate the total cost. But the most important one, the real star of the show, is the diamond. That's your decision point. This is where the program asks a yes or no question, and the path forward can split depending on the answer.
The blueprint is officially done. Now we finally get to the construction phase. It is time to write the actual instructions that tell the program what to do. This is where we use logic to control the flow.
Branching is how a program makes those decisions we talked about, bringing that flowchart diamond to life. It works with a really simple structure. If a certain condition is true, then the program does this. Else, it does something totally different. The key thing to remember, as the guide points out, is that the program only runs the code for the first true condition it finds. It makes a choice, and then it moves on.
The other powerhouse of programming logic is looping, and that's all about repetition. A for loop is what you use when you know exactly how many times you want to repeat something, like do this 10 times. A while loop is different. It keeps repeating as long as a certain condition is true, like keep checking the temperature while it's below 68 degrees.
So, there you have it. Choosing a language, defining your data types, structuring it all with variables and arrays, blueprinting with pseudocode and flowcharts, and then writing the actual instructions with branching and loops. That whole process, that is the fundamental toolkit for building almost any piece of software you can imagine.
From picking a language all the way to logical loops, we've just put together the fundamental blueprint of programming. Every single piece connects to the next to bring an idea to life. So really, the only question left is, with this blueprint in hand, what are you going to build first?